Now let's take a look at example 11. Now we want to verify that z equals to 1 minus I is a root of this equation, z cubed plus 3z squared minus 8z plus 10 equals to 0. Now note that this equation very nicely is an equation. Okay, it's an equation with real coefficients. 1, 3, minus 8 and 10, they are all real numbers. Okay? So how do you verify? All you need to do is to sub into the equation on the left hand side. So I can do this. I can let z equals to 1 minus I, and then I can sub onto the left hand side of this equation, okay, to get this line. Alright, now there is no need to go and work out term by term for each of this expansion if you don't want to, because you can use the GC. You can use the GC to key in these numbers, for example 1 minus I squared, and then you can get your answer. Okay, so once you key in all this in your GC, you can show that they are all 0, which is the right hand side, and so you have verified that z equals to 1 minus I is a root. Okay, now that we have verified the root, the question wants you to now factorize and solve the equation completely. Alright, so what we're going to do, we are going to make use of what we've learned earlier again. Now if z equals to 1 minus I is a root, then z conjugate, please add the star there, okay, equals to 1 plus I must be another root. Okay, now I'm going to do this. I'm going to say that actually, if you look carefully, the coefficient of the cubic term, z cubed, is 1. So that means I can always rewrite this as z minus alpha, z minus beta, and z minus gamma all multiplied together equals to 0, where alpha, beta, gamma are the roots. Okay, and for alpha I can choose 1 minus I, that is z, and for beta I can choose its complex conjugate 1 plus I, and then for gamma I can rewrite this as minus k, so that very nicely I have factorized the original cubic equation. Okay, now once I've done that, then what I can do is I can multiply out the first two terms. Alright, if you multiply out the first two terms, or rather the first two factors, you're going to end up with z squared minus 2z plus 2. Alright, now because the only coefficients that I will get when I multiply this out will be 2k, then 2k must be 10. So if 2k is 10, this gives me the k value of 5. So once I know k is 5, I know that I can write down the roots of the equation. So they are going to be z, z conjugate, as well as minus 5. Done. Alternatively, we could also make use of this formula, z squared minus alpha plus beta z plus alpha beta equals to 0, okay, to help us work out the quadratic factor. Alright, so the alpha that I will use is my z, and the beta that I will use is my z conjugate. So I leave this for you to try. You can work out the sum of roots to be 2, product of roots to be 2 as well. Okay, meaning your quadratic factor will be z squared minus 2z plus 2. Alright, then everything else will be the same as the previous method.